Hello everyone, I am Parmita Biswas, back with you people to give the introduction to machine learning. In the last video, we discussed about what is machine learning, and also at the end of the video, we discussed a small Python program where you can predict things. I gave the example of the pizza, where we predicted the price of the pizza based on the number of toppings and the diameter. Now, you have predicted. In the last program, I think you people remember there was the last thing where I printed what was the predicted value and what was the actual value, that is the target and the predicted. You must see these were not exact. Therefore, there were differences between the two. That means your prediction was not 100% accurate. How do you know it's accurate? Obviously, you have to evaluate something. Therefore, evaluation methods are very important for your model. To know the accuracy of the model, to know how your model is performing, to know how good your model is, to know whether your predicted value will be close enough to the actual or not. For everything, you need the evaluation models. In today's lecture, I'll just discuss about the few evaluation methods and also how they are implemented in Python. Let's move on. Now, you people have an idea about what is classification. In the classification method, we used to classify things as 0 or 1. These are just two classes. For example, it may be you are sick or you are not sick. You are happy or you are not happy. You have fever or you do not have fever. I have said these classes as zeros and 1. You can see the table in yellow and orange. This type of table is called a confusion matrix. This confusion matrix is actually the table where you see what are the number of accurate values, what are the number of wrong things that you have calculated. Now, you can see this table where I have shown what are the actual value and what is the predicted value. I have given these terms as zeros as 1 and 1. 0 means things is not present. 1 means it is present. You can say in binary terms it is true and it is false. Now, if we see the total value, you can see few zeros are predicted as zeros and few zeros are predicted at 1. Again, the opposite. Few 1 are predicted as zeros and few 1 are predicted as 1. If you predict as 1 and your actual value is 1, you are 100% correct. Now, by this particular table and this sample data, let's see what are the things. There are 4 important terms in the confusion matrix, that is true positive, false negative, false positive and true negative. Firstly, let's come to the true positive. True positive means you have predicted it as positive and you are true. That means actual class is 1 and predicted class is 1. That is true positive. Now, if your actual class is 0 and you have predicted it as 1, this means your prediction is false and you have predicted it as positive. That means false positive. Actual class 0, predicted class 1, false positive. Now, if actual class is 0, you have predicted 0. Great news. Again, what it is? It is true negative. But actual class is 1 and you have predicted as 0. That means you have predicted it as negative and you are false. That means it is false negative. Therefore, the two terms which actually will decide, see, TP, that is true positive, TN, true negative. These are correct. You are always correct. If these are maximum, very good. But the other two things are false positive and false negative, where you are false. That means your model didn't predict it correctly. Now, there will be certain data set, there will be certain problem statements and What type of answer do you want? Based on that, you have to decide where can you compromise, FP or FN. For example, if you see a normal, your mailbox must have the feature of spam. If your very important mail, for example a job offer letter, goes to the spam, it's a loss for you. Okay. Now, just see some important other cases. For example, any disease. I am having a disease and the doctor says you do not have the disease. Again, it's a loss for me. Therefore, these cases you have to decide where you can compromise with false negative and where you can compromise with false positive. And in any case, if you talk about the layman, TP and TN should be maximum. Obviously, then accuracy is high. Based on the sample data, which shows the actual and the predicted values, I have covered I have counted every data and then filled this particular confusion matrix. And see, I have found that like TP is 3, FN is 2, FP is 4 and TN is 1. Okay. Now let's see the certain definitions which will be made up of these 4 terms. See, I have already discussed about TP, FN, FP, TN. Okay. And I think till now it's clear. If it's not, please do not move forward. Pause the video or rewind the video. Do the initial example, that is just before the slide, with your hand. It will become easy to you to understand the data sets and what is the actual meaning of certain things. Now, in this, see, in the horizontal part we have written the predicted portion and in the vertical part we have written the observed portion. You can write in the other way also, in vice versa. There is no hard and fast rule, but just be careful where the position of FP and FN will be there. These all the position will change when you swap the positions of observed and predicted. The first definition which comes, it is sensitivity. Sensitivity means true positive out of the total positive in the data set. That is TP, that is true positive. True positive means what are the positive values that you have detected? Out of what? Out of the total positive. What will be the total positive? Total positive that you have detected, and there are certain positive values which you didn't detected. That means you detected it wrong. That would be false negative. Therefore, sensitivity means number of correct positive predictions divided by the total number of positives in the data set. Next comes specificity. That is total negative divided by true negative divided by total negative. True negative, that means you have predicted as 0 and actual class was also 0, which have to be divided by total negatives. Total negatives will be the sum of true negatives and the false positive. That is those positive values which you have detected false. Okay. Next definitions. Accuracy. See, accuracy means correct divided by total. And what were the correct things? True positives and the true negatives. These were the positive things. These were the accurate things that you have predicted divided by total number of events. That is true positive plus true negative plus false negative plus false positive. Simple. This is my accuracy. What is error rate? Error rate is the total number of incorrect predictions. Incorrect prediction means false positive and false negative divided by again total number of events, that is total positive plus total negatives. Next come precision. Precision means it is the number of correct positive predictions divided by the total number of positive predictions, that is true positive. Firstly, true positive means what were actual class as 1 and you have detected as 1 divided by true positive plus false positive. That means in a particular data set, how many you detected as positive and out of that, which were the terms which was actually positive. Similarly, the next is the false positive rate. False positive rate means what were the things that you detected as positive but it was false, that is false positive, divided by true negative, that is it was actually detected as negative and actually also it was negative, that is predicted class 0 and actual class 0, plus FP, that is false positive. That means you detected it as positive but it was false. That means in the actual data set it was negative. This is false positive rate, and if you mathematically see, it is FP divided by TN plus FP, which is again equal to 1 minus SP. Okay, I think we are clear. These are the few terms, I think 1 2 3 4 5 6 terms, which actually tells the different definitions, and because of these definitions we'll have certain curves which actually will be telling how is the accuracy of the model and so on. This is one more example where I have taken some data set, you may say some hypothetical data set, and filled these values, that is observed and predicted, and calculated the every measure. What were the measures? Error rate, accuracy, sensitivity, true positive rate, which is also called as recall, specificity, that is true negative rate, precision, that is positive predictive power, and false positive rate. Also have a look in all the definitions and also all the short forms like ERR, ACC, REC, TNR and so on. Because when you see some problem statement or talk to people, they maybe use some slangs, and this is very important. Like anyone can ask you what is FPR, what is TNR, you should know. I have calculated these values. Okay, I think we are clear here till now. If not, please pause the video, go back and again see what were the different definition and what are the conceptual meaning of the definition. Very important to know where we write false positive, where we write true negative and so on. It's just the name confusion matrix, but it's very simple. There is no confusion in it. Also, one more thing I like to add is that in this case there were only two classes, 0 and 1. It may be 2 or 3 classes like A, B and C. Whether it is truly detected as A, like A can be detected as B and A can be detected as C and so on. Therefore, we can make a confusion matrix where there are 2 or more classes. Now, we will implement this in Python. Firstly, the library that is used is sklearn.metrics. Inside from that, we will be importing confusion underscore matrix. Okay, this is the way how we are importing confusion underscore matrix. Now, this we are using the KNN. KNN is the K nearest neighbor. What is this algo and how this algo works, I'll cover in few other videos. But now you can understand this is a K nearest neighbor algorithm. Okay, we are finding the Y predicted values. X test is my test values. Like you remember, we were dividing the whole data set into the Y test, Y train, X test and Y X train. This is that X test. Now we are trying to print the confusion underscore matrix of Y test and Y predict. See, in the initial example also we had two values, one actual and one predicted. This is the same thing, Y test and Y predicted. Y test will be the actual values because it is a part of a data set, and Y predicted, your model has predicted something. The first thing which you can see in white, that is the normal printing of the confusion matrix. If you want with the labels, like you can see in the second one, we can use pandas crosstab. Pandas crosstab we are also using for confusion matrices, which will have certain written things like predicted, true, false and all. And the other thing, third part, we can print the classification report. That is, it is also present in the sklearn.metrics. When we are printing it, see, it gives the precision, recall, F score, support and the average. These are the three things. Like it's a part of confusion matrix only, and this can be interpreted in 3 different ways. This is a way where you can show how your model is working, how much it is actually predicting and how much it is not. I think we are good here. Let's move on. Next thing, we are going to plot the curve, ROC curve, AUC. What we have done, we have a function predict underscore proba. Now it gives the probability. Okay. Now we are importing ROC curve. ROC curve is a curve which actually shows how your model is working. ROC curve, when we are giving the input to ROC curve as y-test and y-predict proba, it gives the different outputs, that is FPR, false positive rate, TPR, true positive rate, thresholds. Okay, these are the three things. And when we are plotting a graph, TPR versus FPR, that graph is called the ROC curve, and this area under the curve, AUC, gives the value of the area. More the area, better the curve, better the model. See, you can see the 45-degree line. This 45-degree line actually is the worst line. Like below this, obviously you cannot get any curve. You'll get the curve. Above it, more the area it covers, better your model is. Okay. How to draw it? Like I've given the ROC curve. You can see the last value like 0.734. This is the value of the AUC. That is the area under the curve. Okay. That is the R. You can see that function ROC underscore AUC underscore score. That is the AUC score. Area under the curve score. So we have done confusion matrix. We are done with the AUC. We are done with the ROC curve. Okay. So little bit we have the idea about the classification reports, crosstabs and so on. Okay, let's move on. Next is the regression errors. Like we discussed about the regression lines, that is a linear line. I have plotted a normal linear line and some data points which you can see in blue. These are my data points, but if I am applying linear regression, obviously I'll get a straight line. If I get a straight line, you can see my data point do not collide with the line. That means if I'm predicted something, there might be some difference between the actual line and my data point. Again, this is my error. You have to find this error. If you see the difference between the predicted and the actual, it will be absolute error. But if we square it and then find the difference, it will be the squared error. Okay, let's move on and see how to do these. First is the mean absolute error. It is the average of the differences between the original values and the predicted values. Like I just said, you are differentiating it and then taking the average of all the errors. How to do it in Python? I've said it. From sklearn.metrics, you are importing mean underscore absolute underscore error. You are having true values, y true and the y predicted. I've taken it hard coded and then using the function, you can directly printed it out. I have not written the answer here. Please try this. Write the code yourself. You'll get some answer. Change the value. Do it by your hand. You can see whether the value is being matching or not. Next is mean squared error. Now, just in the last slide, which we calculated, we were just seeing the difference and then averaging it. But now if I take the difference, square it, average it, it becomes mean squared error. See again how to implement it in Python is sklearn.metrics. You are importing mean squared error. You are having the y true, you are having the y predicted. Giving the function, the arguments is y true and y predicted, and then you're finding the error. Again, type this command, type this Python small script by yourself so that you can get the value and see whether the value is right or not. One more thing, people, if you are very good at Excel sheets also, then you can also tally your result with Excel sheet and Python. Excel sheet has some data analysis tab where you can find these values, or if you want to calculate this manually, you can write the functions or the formulas by your own. The next one of the important laws is the logarithmic loss. It's also called a log loss. Actually, whenever you are classifying certain things, you see in terms of probability. So what is the probability of A coming first? What is the probability of B coming first, and so on. Now, if you are actually predicted something wrong, logarithmic loss penalizes it. With the further like logistic regression and all, I'll make you more familiar with these terms. But now mathematically, you can see what's the formula. It's the summation of yij into log of pij, where j varies from 1 to m and then again summation of I varies to 1 to n divided by my n, which is negative again, where ij indicates whether sample I belongs to class j or not, and pij indicates the probability of the sample I belonging to class j. Okay, one of the important feature of log loss is that it exists in the range of 0 to infinity. Log loss nearer to 0 indicates higher accuracy. More the value, more the error. Okay. Now, what would be your main aim of log or loss? You have to minimize it. Any type of error, you need to minimize it. Now, I have also given the Python implementation. From sklearn.metrics, we are importing the log loss, and I'm having some data, and then you can find the loss. Now, when you are making the model, you are evaluating the model by using such things. With the evaluation, you are getting some error term, or you are getting some numerical value of the error. You need to decrease it. Therefore, you can also say like the error may again be a mathematical function. You have to decrease it. The error decrease means your model becomes better. If you want to decrease it, like for example, if you get some error term which is a function of square and you have a graph of square, how you do find the minima of that particular function? To find the minima, you have to find the differentiation of that particular thing. You must know about the concept of differentiation and then finding the minima or the maxima. This is the actual topic which is called the gradient descent, and I'll cover in the next video. I'll just implement this in Python also, and the small codes which I have written here, please practice it not only by hand but also by yourself. It will become easy for you. Any type of queries, do ping me, do write, do comment so that I can give you answers. Also, please do not hesitate to click on the subscribe button and the like button. Do watch the videos, share the videos. Thank you. And I think you people know my GitHub link. Other code I have put there for the other type like gradient descent. When I'll give that video, obviously I'll have the code there so that you can practice. Whenever you get some copied code, please do make changes on that particular code so that you know with your changes how the code is being affected, how the output is being affected. Do like the video. Thank you. Thanks a lot for encouraging me. I've got a lot of comments, lot of appreciation for you people. Thanks a lot. Have a wonderful time. Have a wonderful day. Thank you.